Hi, my name is Brian. Welcome to another video on derivatives. In this video, we're going to do another example using related rates. Now remember, related rates are about differentiating implicit functions with respect to t. So let's go ahead and set up the word problem now. A spotlight on the ground shines in a wall 12 meters away. If a man 2 meters tall walks from the wall towards the light at 1.6 meters per second, how fast is the length of the shadow changing when he is 4 meters from the building? So step 1 and 2 kind of work together. Step 1 is about writing down all the information you know and trying to figure out what it is you want. And step 2 is about a snapshot. It's basically trying to draw a picture of what's happening at that moment. So let's go ahead and try drawing a picture down here. Now we have this light here. Let's change colors real quick. So we have our man. And then we have our building. We'll just do this. Now this light is shining onto the man, which is creating a shadow back here. We'll just do that. Now the man is 2 meters tall. We know that the full distance this light is from the building is 12. I guess he's going to be walking away from the building, so we're going to call that x. So he's going to be moving to the left. And then the height of the shadow, or just the shadow, is going to be y. So here's all the things we know. We know that the man is walking, dx dt, at 1.6 meters per second. Now, is it positive or negative? Well, it depends on what you called x. Now, since x is the distance from the building, as he moves away from the building, my x value is increasing, which means my dx dt is positive. Now, what I want is dy dt. dy dt is how much the shadow is changing over time. So I think that's good for the setup. Next, we have to find a formula that relates the variables x and y together. Now, it is a right triangle, so you might think, well, Pythagorean's theorem might be good. But notice that this triangle right here, if I were to take 12 squared plus y squared equals this length, I didn't use x in that formula at all, so that's not going to help us. This scenario happens a couple times in homework sets. It's actually similar triangles is the only way we're going to relate the x and y together. So similar triangles works like this. If you had kind of a bigger triangle, then you have a little triangle that all share the same angles, then whatever a and b, c and d are, we have this relationship that a over b is going to equal c over d. Now we actually have this happening here. We have the big triangle, and then we're going to have the littler triangle here. So let's go ahead and set that up. All right, so this is like your a. So we're going to have a over b, which is the same as y over 12. And then you're going to have the 2 over this. Well, since this is x, this is going to have to be 12 minus x. So the smaller triangle is going to be 2 over 12 minus x. So there's our formula that relates my variables together. So let me write that. Next is we have to differentiate. I think it might be a good idea to multiply both sides by the 12 minus x and then multiply the 12 over here. Mostly because I want to avoid doing the quotient rule when I'm differentiating. So I'll get y 12 minus x equals 24. So I think that works a little better. All right, so let's differentiate. Okay. Let's take the derivative of this side, the left-hand side, and then differentiate. This side's nice. Differentiating 24 is going to be 0. Now over here, it's going to be the product between two functions. We have y and then the 12 minus x. So I have the product rule up there where you'll see that f times g, the derivative will be f prime g plus f g prime. So this is our f, this is our g. Okay, go ahead and do that. So we're going to differentiate the first function y, which is just dy dt, and you're going to leave 12 minus x alone. Then you're going to leave the y alone and differentiate 12 minus x. Well, the derivative of 12 is 0, and the derivative of minus x will be minus dx dt. Still going to be 0. Now remember, we were trying to solve for dy dt, and so that's right there. So I'm going to bring this over to the right-hand side, and then I'll divide by 12 minus x. So that's going to give us dy dt equals, now that's going to be a positive y dx dt all over 12 minus x. Now dx dt I know is 1.6. At this point now I can plug in the x equals 4 here, but I don't know y. When you end up not knowing one of the other variables, all you have to do is go back to the original formula and then notice that if I were to plug in x equals 4 here, I can solve for y. So let me squeeze that up somewhere. We'll have y over 12 equals 2 over 12 minus 4. Well, that's going to be 2 over 8, it's 1/4. So when you solve for y, running out of room. When you solve for y, you are going to get 3. All right, so let's plug all that stuff in now. We get 3, we get 1.6, and then 12 minus 4. And that simplifies to 0.6. Run out of room there. So I'll put it over here. The dy dt at, or when x equals 4, is going to be 0.6 meters per second. Anyways, that is the end of our video. I hope this helps. Good luck. Bye.